Good evening to all of you. In the last class, we have discussed time period of linear pendulum. Today, I am going to take, as I have promised to you, the time period of a non-linear pendulum. So, let us start. The time period of the time period of a non-linear pendulum. So, we make a simple pendulum here. Now, in case of non-linear pendulum, now we have to take a finite angular amplitude. So for this, we assign a bob of the pendulum at say some angle theta naught, and then let it go. So it moves from here, comes to this position, and swing from here and comes to the same angle theta naught. As we have assumed that there is no any dissipative forces acting on the bob of the simple pendulum. So once its to and fro motion started, then it continues for forever. However, in realistic situation, it will stop after certain time interval. But as we know, once we do the scientific experiment, then we have to do under certain assumption. So our assumption is that there is no dissipative medium, that is, there is no dissipative forces, frictional forces, resistance forces acting on the system. That is why it continues for forever. That is the back and forth or to and fro motion is there. Okay, let us say here. So as in the first case, in case of a linear pendulum, because we are taking the mechanical way to understand the time period of non-linear simple pendulum, or you may call it pendulum. So the mechanical way. So we have taken the torque, all the forces acting on the bob of a pendulum about a suspension point, that is the peg, fulcrum, about which it oscillates. Okay, so here is the peg. Mass of the string oval pendulum is supposed to be negligibly small, but it has got certain length L. So the forces are gravitational forces, force of tension acting on this bob. But here in this case, we are not taking the earth and its radius as we have taken in case of linear pendulum. So if you are not taking into account how earth is indirectly is there, so this time we have taken ng is vertically downward. But that time, in the case of a linear pendulum, the force is toward the center of the earth. Okay, so this is a slight shift here to make the things easier, to make it convenient to understand the non-linear pendulum concept. That is why. So here is the mg. Here now we are showing vertically, but in other case toward the center because we made the earth like that. So here the tension always acts away from the body. So the torque of this tension which passes through the peg, the point of suspension, so its torque comes out to be 0 because the lever arm or the moment arm comes to be 0, comes out to be 0, comes out to be 0. So the torque is 0. So what about mg torque? So this is the point about which we have to find the torque. We take the radius vector in that direction. So this is the radius vector r. So torque is r cross f. Here f is mg because we have taken the torque of already the force of tension T. So r cross f means r cross mg vector. So magnitude of r vector. So this is the magnitude of the force vector mg. Sign of the angle between them. So if we like that here. So this is the alternate angle. This is the vertically opposite angle. That's the theta. In fact, theta naught. So we have taken here theta. This is the angular amplitude, theta naught. Angular amplitude. Okay. And now we have taken a theta. So theta, it means just in course of motions. So somehow let us say here, we imagine like here. So this is theta. So draw the forces here as well. This is mg and this is the tension T. So this is sine of the angle between the theta. Okay. And the unit vector m. We are writing here magnitude. That is why the magnitude of unit vector is unity. Because unit vector has no unit 1. This is the torque. As we know in torque equation, net torque must be equal to I alpha. However, take into mind, it is not the case of always. We always do not take torque equal to I alpha. We will take this thing in detail in the rotational dynamics. But somehow, in some cases, we take torque is equal to I alpha. So this is equal to I what? This peg, say O. I O. But thing is here, so if we leave it at angle say theta now and we release it there, so it comes towards the position from where it has been displaced. So this torque is restoring in nature. So that is why I put the minus sign as we have did in the last class. So this implies alpha is equal to minus mgl sine theta over I naught. So I naught, the moment of inertia of this bob of mass m about this peg. So perpendicular distance is L. So we did in the last class in the case of linear. So here mgl sine theta over ml square. So m is not 0 and already defined quantity, so cancel out same as to L, so cancel out, it comes out to be minus g by L sine theta. So this time, because it is the non-linear case, so we cannot write sine theta as a theta. So that is why sine theta remains here. That is why it is the non-linear. So look at how one can find the solution of these differential equations. Why we call it differential equation? Because alpha is written as d2 theta by dt square. And this is equal to minus g by L sine theta. Bring right hand side 0. So this is d2 theta by dt square plus g by L sine theta is equal to 0. So we have to solve this differential equation to get the answer of the time period of non-linear pendulum. So we have what we have to do. So this is seems to be beyond the course of class 12. Yes, of course it is. But in the class 12, we have to study little bit differential equation, and one of them is linear differential equation. However, it is not a linear one because the linear in the sense of the x, y, x like that. So here is the alpha. So by inspection, we say that its integrating factor is d theta by dt. So we write here by inspection d theta by dt is integrating factor here, integrating factor. So what we do, we have to multiply this by this integrating factor both the sides. Let's see. So we multiply both the sides. This implies d theta by dt, d2 theta by dt square plus g by L sin theta is equal to 0 into d theta by dt. So we are multiplying both the sides. However, it is integrating factor, but we cannot multiply both the sides by a quantity which is 0. So we have to assume here d theta by dt is not equal to 0. So here d theta by dt is not equal to 0. What about definition? It is already defined, that is why we are multiplying. So now I have to solve like that. So here this implies that, and we may write like that here, d by dt of half d theta by dt whole square minus g by L cos theta this is equal to multiplying by the any quantity with the 0, any defined quantity multiplied by 0 comes out to be 0. So how one can say this is correct? So differentiate and you will get the same things here. That is why. Now after finding its anti-derivation, so we may not call it here integration. However, most of the teachers saying indefinite integration and definite integration. But I say anti-derivation and integration. And there is no any distinction between indefinite or definite integration. Integration is integration. So now we are going to find the anti-derivation here. So this implies half d theta by dt whole square minus g by L cos theta is equal to say c, where c is anti-derivation constant, where c is an anti-derivative constant. Now, so first task is that we have to find the anti-derivative constant c. For this, we take the initial condition at t is equal to 0, theta is equal to theta naught. So put that, so it comes out to be half d theta, no, this is the way, right, first time, okay, d theta by dt whole square minus g by L cos theta naught, and this is equal to c. So when theta is equal to theta naught, it means you are holding it there and then you have to let it go. So once you are holding the above the pendulum at theta equal to theta naught, it means theta is not changing. So that is why d theta by dt comes out to be 0. Why 0? At theta is equal to theta naught. At theta is equal to theta naught, it means we are holding the above the pendulum. It means that theta is not changing. So d theta by dt is equal to 0. So now this implies c is equal to g by L cos theta naught with the minus. Now put it there. So little bit simplification is here. So do not worry about that. These all are acceptable and you are going to understand if you have a little bit intention towards it. Let us see, put there. So now this implies half d theta by dt whole square minus g by L cos theta is equal to minus g by L cos theta naught. This implies d theta by dt whole square is equal to twice g by L taken out, now becomes cos theta naught minus cos theta. So d theta by dt is equal to square root of twice g over L under root cos theta naught minus cos theta. Okay, so here the plus minus, as we know, x square is equal to 4. As you know, x square is equal to 4. This implies x equal to plus minus 2. Okay. But here d theta by d taken as a omega, as a positive, so the negative square root has been left out. Only we have taken the positive square root. That is why plus sign has been written here. Otherwise, in general, plus minus. So now we are going to use an identity or a formula, a well-known formula, geometrical identity. So here cos theta is equal to 1 minus twice sin square theta by 2, and cos theta naught is equal to 1 minus twice sin square theta naught. After putting this, let us see. So now this implies d theta by dt is equal to, so if you put like that, then this factor has been cancelled out, root 2 is already taken it out, so it becomes here twice under root g by L. It's totally simplification, you are also able to do that. So now this becomes here sin theta by 2 minus sin theta naught by 2. After putting that, you are also able to do that. Sin theta by 2 minus sin theta naught by 2. Look at the simplification there. So here d theta by d2 is in this way. So this becomes positive and this is already negative. So we did mistake here. Point it out. So this is positive and this is the negative. Now in this way, this is the negative sign and this is the positive one. So now scenario has been here different. So here is the minus and here is the plus. I did it deliberately, but I have examined what I did. So we find there is the manipulation of minus sign is there. That is why we have been rectified it in this way. So this is the story here. Now what we have to do? We want to find the solution here. So we assume that we take here, say small k is equal to sin theta naught by 2. Okay, and sin theta by 2 as sin theta naught by 2 into sin phi. So just we assume, we take. Now this implies sin theta by 2 is equal, this is say k, is the fixed theta naught is the amplitude. So it is a constant taken as k. And this is here sin phi. Now this is sin theta by 2 is equal to k sin phi. K sin phi. Now we have to put here Sin theta by 2 is the k sin phi, and this one theta by 2 notice the k already is there. So here again we did a mistake here because here the square. So take care, here is the square. Okay. So that is why now put this into the above result. So what we are going to get there? Look at here. So in this way, this implies d theta by dt is equal to twice under root g by L. Now here sin theta naught by 2 taken as k. So this becomes k square, and the sin theta by 2 is taken as k sin phi. So this becomes k square sin square phi. And here, so now this becomes twice under root g by L, and then taking k square is common. The k is outside. 1 minus sin square phi is taken as positive square root. Cos square phi comes out to be plus minus cos phi. We take the positive square root at the cos phi. So this becomes k cos phi. So this is the case here right now. So now what we have to do? Look at here. Now here d by dt of theta by d by dt of sin theta by 2. This is equal to sin theta by 2 cos theta by 2. Then this is d by dt of theta. What is sin theta by 2? Look at here. Sin theta by 2 is taken as k sin phi. Look at here. K sin phi. Put it here. D by dt of k sin phi. Now this is equal to what? Cos theta by 2 d by dt of theta. Okay, this side here k is constant taken out. D by dt of sin phi. Dt of sin phi. The cos phi and the phi d phi by. So this is cos phi and d phi by dt. Here is the d2. Same thing is there. Now, what is the result here? K cos phi. So we have to put in place of k cos phi as these things by that things. Okay? So now we put. So what we have? D theta by dt is equal to twice under root g over L. So what is k cos phi? Take k cos phi from here. So it is cos theta by 2 d by dt of what? Theta by 2 over d phi by dt. So this is the result right now. So now take 2 here. So this becomes d by theta by 2 of dt. This is equal to under root g by L. This is cos theta by 2. This is d by dt of theta by 2 multiplied d phi over dt. So in this way, so this quantity is to be cancelled because assuming this quantity is defined and at the same time is not equal to 0. So because we are going to cancelling the unknown term, so we must care about that. Assuming this is not equal to 0 and already defined, so it is cancelled out. Only after assuming this is not equal to 0. So now this implies d phi by dt is equal to under root g over L cos theta. Now this implies d phi over cos theta by 2 is equal to under root g by L into dt. We cannot say it is a cross multiplication. It is the differential coefficient form and the differential equation form. So we do not mean that after cross multiplication we get this one. No, it is not so. So now again, so here is the cos theta by 2, and we have been assumed already sin theta by 2 is equal to k sin phi. So we write now. So this implies, so we are writing these things firstly here in the left hand side here. So this is g by L dt, and this is equal to here d phi over cos theta by 2. This is taking positive square root under root 1 minus sin square theta by 2. So this is under root 1 minus sin square theta by 2. What we have been assumed is the d phi. This is under root 1 minus sin theta by 2. Already we have been assumed earlier. This is the k sin phi. K sin phi and comes out to be whole square. So now this becomes d phi over square root of 1 minus k square sin square phi. So we arrived at this stage. Now at this stage we have to assume the initial condition. What is the initial condition? We are well aware about that. But keep in mind here, sin theta by 2 is sin theta naught by 2 into sin phi. Use the initial conditions. What is the initial condition? Say at t is equal to 0, what? Theta is equal to theta naught. And d theta by d equals 0 is also the case here. Is equal to 0. Now, just we are going to change the limit because our function is phi, but earlier is the function of theta. So accordingly, we have to change the limit. Look at here. This is our pendulum. This is the peg, bob of mass m. So we have been assigned this pendulum, say at angle theta naught. Angle theta naught. So here is the theta naught. If theta is equal to theta naught, what will happen there? If theta is equal to theta naught, then sin phi is equal to be 1. How it comes out to be 1? Because sin theta by theta naught by 2 from both the sides cancelled. Why cancel? This is a known factor? No, it's certain angle theta naught. So certain angle which is acute one, sin has got some non-zero values. That is why this implies when theta is equal to theta naught. So this is sin theta by 2 is equal to sin theta naught by 2 into sin phi. So this implies sin phi is equal to 1. This implies phi is equal to pi by 2. Now 3 pi, 5 pi by 2, not 7, 9 pi by 2, and so on and so forth. Because 3 pi by 2, sin of that 3 pi by 2 comes out to be minus 1, and 7 pi by 2 comes out to be minus 1, because it is the 1. So, but our solution here resembles with these other conditions. Theta is equal to phi is equal to pi by 2. In this particular scenario, however, these are the mathematical possibilities, but in this physical possibilities only we have to take phi is equal to pi by 2. Now this is the one. Another story is that, so if we here let it go, comes here, goes there, like to and fro motion. In this way, comes here, swings away, and then back, goes there. So suppose just we are watching, it is going from here in that way. So it arrived there, extreme position, comes at the mean position, again arrived at opposite, minus theta naught. This is theta naught, customary called minus theta naught. So again extreme position, comes back. So time required to go from mean position to the either of the extreme position is the 1/4 of a time period. So now we get our limit both the sides by using initial condition. Okay, so here at t, so you have to write the time t equal to 0 to up to what? So we have to go through from mean position to the either side of the extremum. So t is equal to 0 to t is equal to t by 4, because just we are watching from mean position to the either side of the extreme, like that here. So now what we have to do, look at here. So under root g over L dt, this is equal to d phi over square root of 1 minus k square sin square phi. So put limit here 0 to t by 4, and here the limit is 0 to pi by 2. Now the left side is quite easy. So this is under root g over L, and it comes out to be t by 4. That is quite easy. So now on the right hand side, so here the right hand side we have to write again in the same form like 0 to pi by 2. Here is the d phi over square root of 1 minus k square sin square. Now up to this stage, no problem at all. Even for class 11th and 12th class student, right now there is no problem, because the class 11 12 students are capable to do in mathematics. I'm not talking about the PCB students, maybe PCB students, but you are the PCM students, you are able to do harder than that type of chemistry. So here up to this stage, no problem at all for any level students, 11, 12, 13, 14, 15 as well. Okay. So here is something which is not to be discussed in class 12 syllabus. So the value of this right hand side, value of what here, value of this 0 to pi by 2 d phi over square root of 1 minus k square sin square phi, sin k square is not an elementary integral. Then what is this? It is a complete elliptical integral of first kind. No matters for class 12 students, take it into account as if in class 10 you have taken area of circle as a pi square without knowing how it came into existence. In the same line, you take this thing is there in graduation or MSc course, you will see in very detail of this one. So this is, so it is maybe expanded as a power function. So as a power function. Now this one, I'm going to erase this one. So the value of this one, 0 to pi by 2 d phi over under root 1 minus k square sin square. This is comes out to be by using the power series. However, it is also beyond the class 12 syllabus, but we are using for the sake of interest of non-linear pendulum. However, only here the few steps are beyond the scope of your syllabus, but before that you are capable to understand. However, typically in the calculation, of course. So this is pi by 2, 1 plus 1 over 2 whole square, k square plus 1 into 3 over 2 into 4 whole square, k to the power 4 plus 1 to 3 into 5 over 2 into 4 into 6 whole square, k to 6, and so on and so forth. Now what is the k? The k is sine theta naught by 2. Now we use here as the Taylor series, the expansion of these sine functions. So we all know expansion of sine theta is equal to theta minus theta cube over factorial 3 plus theta 5 over factorial 5 minus plus and so on and so forth. On the same line, we are going to write in terms of series of sine of some angle. Look at here. So this is the theta here, theta naught by 2 minus theta naught by 2 whole cube factorial 3 plus theta naught by 2 5 factorial 5 minus plus and so on and so forth. If we are going to put the k values there, so we will get the value of this power function. So what is the value of this power function? So 0 to pi by 2, here is the d5 over under root 1 minus k square sine square 5. So this comes out to be pi by 2 1 plus, this comes out to be theta naught square over 16 and so on and so forth. Now our task seems to be complete. So this implies here t is equal to 4 under root L by G and then pi by 2 bracket here 1 plus theta naught square over 16 and so on and so forth. So this is the time period of a non-linear pendulum. Whatever theta naught, we do not think theta naught is greater than pi by 2 or pi by 2, no matter, so little less than pi. We may take pi by 2, but generally less than pi by 2. So not more than pi by 2. So how one can oscillate like that? It may be slack and somewhere else like that. So we'll take this type problem in the work energy power. So theta naught is small but acute angle. Whatever the acute angle, put there and get the answer. But right now, look at here our famous result in case of linear pendulum. However, when length of the pendulum is very, very less than radius of the earth. So in that case, we take here theta naught tends to 0. Limiting case here. That's the case 1. In case of linear pendulum, what we have seen earlier in the last class. Okay. So if theta naught tends to 0 plus, so this time period comes out to be 2 pi under root L by G. Very famous in case 1 in the earlier class. If theta naught is not very large but small but finite, small finite. So if theta is equal to theta naught is small but finite, not tending towards 0. So we may take it to the two terms and leaving the higher order terms. So that is why theta, but not in degree measure. It is in radian measure, of course, taken into mind. So theta here is in the small, but in radian measure, not in degree measure. It is in radian measure. So it is in radian measure. So now the time period comes out to be t is equal to here 2 pi under root L over G and then multiply 1 plus theta naught square over 16. So here the two cases only. So even theta tends to 0 plus and then next and theta is a small, finite, but still small. Up to which degree measure, up to which radius measure, still it is dilemma to say like that. 1 degree or 2 degree, 3 degree, 4 degree, maybe convert into radians. Still we are not able to say like that. But it is small, very, very small. Not tending towards 0, but very, very small. So here we are not going to recognize in so many textbook and so many teachers teaching the 4 degree up 2 or 3 degree. We are unable to say like that here at this stage. So only they say theta is small but finite, not tending towards 0 somehow, because we have to negate the higher order terms. That is why I am telling you like that. So now this is the process. Now it finishes the heading, the time period of a non-linear pendulum. Non-linear. So okay. So we take here, and next class probably we will take up how one can find the time period of a simple pendulum by using dimensional analysis. However, we all know dimensional analysis has certain limitations, certain restrictions. Just I am going to say its restrictions are: number one, result cannot comprises more than 3 fundamental quantities, and the number two, result must comprises one term only, and the most important, the third condition and the last one is we cannot see anything about in a physical relation if numeral occurs, because numeral has got no dimension. So we are unable to find the numerical values because it has got no dimensions. So in which cases, say if angular amplitude theta naught occurs, if the ratio of the two similar physical quantities occur, so the A by B or R, small r by capital R, or might have been the ratio of the same thing is there. So the ratio of the same things means it has got no unit, no dimension. So we are unable to find the numerical value by dimensional analysis. So we have to discuss here the limitations, and hopefully we will take how it comes into play. Okay, thank you.